prepared with the help of, this is called as a nitriles cyanide, alkyl cyanide. This is called as a commonly called as a nitriles. Nitriles also in presence of lithium aluminate. We are getting of the simple formula of, that is a primary amine will be used, that is CrCH2NH2. This will be obtained with the help of, particularly if you want the example for this one, acetonitrile, that is CH3, CH3CN acetonitrile. It is a formation of that one. Acetonitrile or methyl cyanide. Okay, this is acetonitriles. This is commonly called as methyl cyanide. Methyl cyanide. When in presence of lithium aluminate, getting of CH3, CH2, NH2. Okay, so ethyl amine is prepared. It is also primary amine, I think, but primary one. Okay, suppose in case of isonitriles, means NC, that is isonitriles. As isonitrile, you are getting off by means of this isonitriles. In presence of lithium aluminate, you are getting off secondary amines, RNHCH3. This is the formation of secondary amine is prepared. Okay, see the difference between the reduction process. From this isonitrile, you are getting off from a primary amine. By this, we are getting off isonitrile. Okay, so isonitrile, you are getting off the secondary amine. Similar manner, you can also take as a one more reduction, amides, RCONH2. These are the called as amides. Amides also reduced in presence of lithium aluminate. Formation of same primary amine is obtained, that is RCH2NH2. This is the primary amine. We are used that one. Okay, acetamide, we are getting off ethyl amine like that. Suppose secondary amides, RCONH, we are using, this is the case, in this case primary, these are the primary amides. Suppose we are using of the secondary amides, RCO, okay, NH, instead of hydrogen, we are replacing one alkyl group, R again. This is called as secondary amide. When secondary amide is reduced in presence of lithium aluminate, you will getting of secondary, that is RCH2NHR. That means secondary amine is prepared. If it is tertiary amide, you can take tertiary amines will be prepared. That is the difference between the remaining other reactions. Okay. So reduction process, the general reduction is alkyl, that is a nitroalkanes. We are getting of the primary amines only. By means of cyanide, we are getting of means of nitriles, we are getting the primary amines. Isonitriles, we are getting of secondary amines. From the amines, primary amines, we are getting of the primary amine. Secondary amines, we are getting the secondary amide. Tertiary amides, we are getting of the tertiary amines. Okay, this is about the preparation of yours.
So the bottom is not visible. The bottom of the board.
Bottom is nothing but secondary amide. In the secondary amide, lithium aluminate reduction formation of RCH2NHR. That means nothing but it is a secondary amine will be prepared. Okay.
Yes,
right.
sir.
And other main important preparation here, these are the general preparations of the amines. And two more important reactions are there. That is Gabriel-Thallamide reaction. Gabriel-Thallamide reaction is there. Schmidt reaction is there. By that also you can prepare the primary amines. Okay. So the next important reaction in this preparation is we are having of the first reduction is over. Second is Gabriel-Thallamide reaction. Okay, Gabriel thalamide reaction is nothing but potassium thalamide is reacted with the alkyl halide. When you are getting of the derivative, that derivative is hydrolyzed. We are getting of the primary amine. Very simple reaction. But the Gabriel thalamide reaction, we are using of the phthalic acid. That is potassium thalamide. Potassium thalamide is used in this main important raw material. Okay. So the potassium thalamide is nothing but we are using of. This is the potassium thalamides. Okay. Potassium thalamide. This potassium thalamide is reacted with presence of alkyl halide. I am using of this alkyl halide. Intermediate product is obtained. That is the derivative. Instead of the potassium thalamide, formation of alkyl thalamide is obtained. Kx is removed out. Immediately after we are using of hydrize, that means HO3 plus, or you can say OH minus hydroxide ion. Simply, this is a thalamide will be formed as phthalic acid. This is the phthalic acid. I didn't write the intermediate product. Directly, I am writing the product only. Intermediate product is there. I skipped the intermediate product for the examination point of view. You should understand. When potassium thalamide is reacted with alkyl halide, a derivative from that is intermediate product is formed, removing of the potassium halides. So alkyl thalamide, that is the formation will be there. Nitrosyl, nitroalkane. This is the formation NR. Okay. So then hydrolyze, we are getting of the phthalic acid plus RNH2. Primary amine will be prepared. This reaction is called as Gabriel thalamide reaction. So Gabriel thalamide reaction, it is very important in your examination point of view. Sometimes it is separately asking for the examination as a 5 marks question. Okay. This is in your book. This book it is given as a complication. Somewhat complicated, not totally complicated. One intermediate product is given. So after that, we are getting of this one. So we are wrapping up the potassium. This phthalic acid is removed out. Primary anyway will be formation. Next, third is the schemic reaction. It is also very important. Name reactions are always important. If the two questions, 5 and 5, this 10 marks question may also ask, but in that examination point of view. So write the Gabriel thalamide reaction and schemic reaction. Simply here, nothing but the carboxylic acid is reacted with the hydrozoic acid. Carboxylic acid, RCOOH, reacted with the hydrozoic acid, N3H hydrozoic acid. Formation of simple compound, that is the primary amine is obtained, RNH2O. And carbon dioxide, nitrogen is liberated out this case. Carbon dioxide, nitrogen is liberated. Both are the gases. These are the gases which can be removed out. We're getting of the primary amine. Okay. Suppose if you're taking of the benzoic acid, benzoamide, that is a benzoic acid also same. Now instead of we are using of the example, why? Because only one year reaction is there. Take one example. So acetic acid, we are taking of acetic acid. Instead of R, we are taking a methyl group. When the hydrozoic acid, this is called as hydrozoic acid. When hydrozoic acid is reacted, formation of methyl amine, primary amine, methyl amine, and carbon dioxide and nitrogen is liberated out. Suppose in the case of benzoic acid or COOH, okay, when benzoic acid is reacted with the hydrozoic acid, same thing will happen. So benzoic acid reacted with the hydrogen acid. What happened here? The carbon group, whatever the carbon is present, that will be reacted on this particular that one. The formation of aniline. Aniline is the primary amine which are present. Okay, so aniline is formed plus same carbon dioxide and nitrogen is liberated out. This is called as a schemic reaction. So the preparations, whatever the preparations are given as the three only, reduction preparations are general preparations are there plenty of there. In the directly they ask what are the preparations of amines, that is enough for reduction. All reactions you can ask. But especially, particularly they will ask the name reactions separately, Gabriel-Talmide reaction and schemic reaction. Suppose in the examination they are not asking the separate means, you can also write these are two are the comes under the preparations. Okay. So next is the properties. If you go to the properties, here the most important the physical properties are the basic strength of the amines. Alkyl amine, that means primary amines are more basic than the ordinary ammonia. Why? Because there is an inductive effect is present. There is R nitrogen is having of the nitrogen atom is having of the electron density is increases of this nitrogen atom. Due to that reason, these are the more basic nature than the ammonia. When you compare it with the aniline, aniline is a less basic than the ammonia. But the primary amines means alkyl amines. Alkyl amines are more basic than the ammonia because of due to increasing of the electron density which are present on the nitrogen atom. That is the reason only. Okay. Due to that reason, these particularly alkyl amines are more basic in nature compared to the ammonia. When you compare to the ammonia, aromatic amines are less basic because of there is a plus I inductive effect is there. These are the mesomeric effect is there. Plus M effect will be there on this nitrogen atom. Here inductive effect is there. Here the mesomeric effect is there. That you have to difference between the two aromatic carbon atom as having of the mesomeric effect plus M effect. It is called as a plus I effect. That is the two differences are there. These are the more basic than the ammonia. These are the less basic than the ammonia. That is the difference. Okay. Now coming to the chemical properties, we are having up the some of the chemical properties in this way. Very important is only the separation of the ammonia by the Innsbruck's method. It is a long question, essay type question. Separation of the ammonia, that means mixture of ammonia, primary, secondary, tertiary amines are mixture were taken that will be treated with the Innsbruck reagent. Innsbruck reagent is nothing but methyl, that is a benzyl sulfonyl chloride, C6H5SO2Cl, that is called as a benzyl sulfonyl chloride. It is also called as Innsbruck reagent. So in our textbook, it is given clearly a flow chart is given as the flow chart, outline of the flow chart. From that, you can identify you can separate the primary, secondary, and tertiary amines. Page 70, page number 70, a clear picture is given. So in that, what happened? The mixture of amines means primary, secondary, tertiary amines are taken. Okay, they are filtered with the ether. So immediately the quaternary salt, the quaternary amine will be separated out. Remaining the mixture is consisting of primary, secondary, tertiary amine. These primary, secondary, tertiary amines are treated with the Innsbruck reagent, that is the benzene sulfonyl chloride. Only the primary amine will be primary and secondary amines will be reacted with the Innsbruck reagent, and tertiary amines are formation of the salt. So you can easily separate out the salt. Remaining only the mixture will be consisting of primary, secondary amine. This will be extracted with the dilute acetic acid. Immediately what happened? Primary, secondary amines are soluble and tertiary amines will be separated out. That means salt is formed this one. So tertiary amines is removed. In this case, in the ether phase, that is a primary, secondary amine, again, we are treated with the sodium hydroxide. In the sodium hydroxide, only the particularly we are having of the primary amines will be formation of ether phase, and also the particular secondary amines will be formation of a salting phase. Then secondary amines will be removed out. Then in the first primary amines again neutralized with the sodium hydroxide, you are getting of the second primary amine. This is a flow chart is given in your page number 70. I don't want to write all this page because we are having the less time, and only one more class is left tomorrow only. I can complete all the topics, little bit of area. So better, this is a compulsory question in your examination point of view. How can you separate the primary amines? Means
Sir,
only the
only
thing is
flowchart is enough, right? So, or we
that
have to
is
write
enough.
also.
That is enough. That is enough. Total
Okay.
short is enough. You are separating. How we are separating? We are using the mixtures. That is a no need to write the separate equations. Only the flow chart is important. Okay, that you are giving. Why? Because the mixture is consisting of primary, secondary, tertiary amines that is treated with the Innsberg reagent. That is benzyl sulfonyl chloride. By that you are getting first you are removed of the tertiary amine. Second you are removed of the secondary amines. Lastly, you remove the primary amines. That is the case we are having of the flowchart that will be there. Next is one more question is there. The same page number 71 after the 71. That is in your book is given as reaction with the nitrous acid. Actually, the nitrous acid is very important. It's differentiation of how can you differentiate primary, secondary, tertiary amines. That is a very important. Primary, secondary, tertiary amines can be differentiated with the help of nitrous acid. When you treat it with the nitrous acid, the formation of benzene disonium chloride. Primary amines are treated with the nitrous acid at about 0 to 5 degrees. You are getting a benzene disonium chloride. You know that the benzene disonium chloride is very, very important raw material used to prepare so many other organic compounds. Here, what happened? Primary amine is reacted with the nitrous acid. I can write the in your book. It is not given actually differentiating primary, secondary, and tertiary amines from nitrous acid. It is a 5 marks question compulsory. Okay, so you are having of the nitrous acid is a mixture will be taking place. In this case, we are using of the sodium nitrate plus HCl. That is the two are taking in your laboratory. We are preparing of the disonium chloride is taken. Okay. So for that purpose, I'm taken as this first case where I'm using of the primary amine. It's a primary amine. It treated with the sodium nitrate, NaNO2 plus HCl. Both you are keeping the temperature only less than 5 degrees Celsius only. Then only the reaction will be takes place. Otherwise, reaction does not takes place. Aniline is taken in the exam. In your laboratory, you are taking the aniline is treated with the 5 ml of sodium nitrate and 5 ml of HCl, which are keeping in the ice bath. That means you have to maintain the temperature is 0 to 5 degrees Celsius and only. We are getting off R N2Cl. That means we are getting off the disonium chloride is formed. This is disonium chloride. When this disonium chloride on hydrolyzed, we are getting off alkane, nitrogen, and HCl is removed out. So this alkane again hydrolyzed, we are getting off the alcohol is formed. Okay, this is the main important of the disonium chloride. Okay, right? Actually, this is not prepared in the laboratory, but actually we are preparing the phenyl, that is aniline. Aniline is taken. This is the primary amine. It is reacted with the sodium nitrate and HCl. We have to maintain the temperature is 0 to 5 degrees Celsius. We are getting out benzene disonium chloride. This is benzene disonium chloride. This is a form when this benzene disonium chloride is treated with so many other we are getting of the products. And the second case, we are taking of the secondary amine. When the secondary amine is treated with the nitrous acid, that means HNO2, only nitrosoamine will be formed. Okay. So formation of secondary amine when you treat it with the nitrous acid, this is a mixture is formation of nitrous acid only. HNO2. Sodium chloride is a byproduct is removed out. Okay. So formation of nitrosoamine will be formed. This is RN double bond O. This is a nitrosoamine. N nitrosoamine will be formed. N nitrosoamine. Here simply formation of the alcohol, nitrogen and removing of HCl. But secondary amine you are getting of nitrosoamine will be formed. If you are taking of the tertiary amine, when you are taking of the tertiary amine in presence of nitrous acid, In presence of nitrous acid, a salt is formed, completely getting of the salt, that is a HNO2, getting of R3N. HNO2 is a salt which is formed, that means it is not, does not giving off any products. A derivative is formed. By means of this one, we can easily differentiate the primary, secondary, tertiary amine. By means of primary amine, we are getting of the alcohol. But here, nitrosoamine is formed. Here, a salt derivative is formed. This is a important reaction that is a particularly differentiating the primary, secondary amines will be formed. Next, important chemical reaction in this case. First is the separation of the mixture of amines by means of Heisenberg's reagent. Okay. Second is the with the nitrous acid, you are differentiating the primary, secondary, tertiary amines. Only primary amines. Test for the primary amines. One more name reaction is there. Test for the primary amines. That is also very important. Which this reaction also you can use in your laboratory, that is called as carbyl amine test. Carbyl amine reaction. Very important, this one carbyl amine reaction. Simply, particularly aromatic hydrocarbons, that means aniline is aliphatic or aromatic, whatever you take, that one, that particularly treated with the chloroform and in presence of potassium hydroxide, you are getting of the unpleasant smell will be, that is isocyanide is formed. Very unpleasant smell will be getting off that one. That indicates the compound, the mixture is consisting of the primary amine is there. So if you are using of the aliphatic amines as well as the aromatic amines, this test is very useful. Suppose if you are taking of the example of methyl amine, this methyl amine is treated with the chloroform CHCl3 in presence of base, that is potassium hydroxide. You are getting of methyl isocyanide is formed. This is methyl isocyanide, which is very dangerous one, and also liberate out the water and KCl will be liberated out plus 3 KCl. But mainly important is aniline. We are taking off aromatic amine. We are testing in the carbyl amine test in the laboratory. When the aniline is treated with the chloroform, this is the chloroform. This is aniline and base potassium hydroxide, methyl isocyanide, the benzyl isocyanide is formed. This is very unpleasant smell will getting off, very foul smell. Okay. This particular compound is while you are taking of these two are pouring into the aniline round bottom glass 5 ml 5 ml are taking off. Immediately the reaction proceeds. We are getting off isocyanobenzene is formed. This isocyanobenzene is a very unpleasant smell. We are getting off the 3 molecules of water, 3 molecules of PCl is liberated. This reaction is called as carbylamine reaction. This indicates the test for the primary amine. Only it will give the result of the primary amines. If you are taking the secondary amine, this reaction does not proceed. Tertiary amine does not proceed. Only primary amines you can test for this primary amines. This is about the carbyl amine reaction. Okay. So these are the chemical reactions which are using of this particularly. Next reaction of aromatic amines which are having of in our textbook, but no need of that one. Only aryl diazonium salt. Just now we are using of the aniline is treated with the nitrous acid formation of aryl, that means benzene diazonium chloride. They'll ask separately, how can you prepare the benzene diazonium chloride from aniline? This is the one more extra question and using of preparation of 5 marks bit. This is asking preparation of benzene diazonium chloride. It is already repeated one. Again, I am brushing this one. Only you are taking off aniline. When aniline is treated with the sodium nitrate and HCl. These are the two ingredients which are taking, and the maintaining of the temperature is 0 to 5 degrees. You are getting off benzene diazonium chloride. This is the plus and Cl minus. Okay, and you are getting out benzene diazonium chloride is formed. This is the preparation of, if suppose the question will be asked how to prepare the benzene diazonium chloride from aniline, or they'll ask directly how to prepare. You have to prepare from the aniline only. You are getting off this one. Or we are using of how to prepare the benzene from the benzene diazonium chloride. So benzene means you have to first nitration. I'm using of from benzene. I'm taking off the benzene. This is a benzene. Is it treated with the nitration mixture, that is H2SO4 concentrated and HNO3. It is also maintained 0 to 50 degrees centigrade only. Both are the concentrated. You are getting off nitrobenzene. This is the nitrobenzene. This nitrobenzene on reduction, zinc or HCl or tin or HCl, formation of aniline. This is aniline is formed. This aniline is again diazotization in presence of nitrous acid. Again the reaction proceed. Formation of benzene diazonium chloride. Whatever the question has, you have to write this all these things. Okay. Sometimes the examiner will ask how to prepare the benzene diazonium chloride from the benzene. You have to take this one. Or if you suppose simply they ask the preparation of diazonium chloride means simply taking off from aniline, you can get the one step. But here the multiple steps are there. You have to prepare that one. This is about the this chapter, and the next one you can go the optical, that is mainly important of the stereochemistry of the carbon compounds. Here the stereochemistry, very important of the stereochemistry will be there, but in this case these are laborious. I will give the only few examples in this stereochemistry. First of all, page number 86, we are having of the lactic acid is there. There is a mirror in enantiomers are there. Page 86, go through that one. Enantiomers will be formed, lactic acid as well as other. These are all DID is there. Only two examples is enough, lactic acid and glyceraldehyde. Next, we are having of them. If the compound is having a molecule is having a two dissimilar asymmetric atoms. Here in this lactic acid and glyceraldehyde, we are having only one asymmetric carbon is there. But if we are having of the two asymmetric carbons, we are having of one more example. That page number 89 is given. Next is the racemic mixtures. They ask the racemic mixture, page number 91. It is there. How the racemic mixtures are prepared by means of the mechanical method, biochemical method, and then the fractionation method, which we are using of that one.
Sir, it is an important question, sir.
These are the important questions in that chapter. Why? Because the stereochemistry is a lengthy process. I can't explain within the few minutes. There's a racemic mixture is there. You have to draw the whatever the configuration, what you are getting of the racemic mixture. Go to mirror images are formed. That mirror images will be called as a racemic mixture. In that racemic mixture, we are having the optical rotation will be there. RS configuration is there. Everything. So it is a very, very lengthy process. That's why I'm using only the few important questions which are coming in the regularly in the examination point of view. Okay. And next we will go to the next chapter. That is again the introduction of confirmation analysis. This is also very, very, I can't explain in detail in this classroom. Okay. Only few examples I will be explaining this particular conformational isomers of page number 110. Butane is given. The butane gaseous form, antiform is there, cis form and trans form of butanes are given. Page number 110.
Sir, butane.
And next one, the conformational analysis of N-butane, page number 119. Seaside form, gaseous form, eclipse form is there. So you are having of the sixth conformation of the N-butane is given. If you are having of the idea, only you can go through this one. Otherwise, leave this chapter. No worry, don't worry about this one. Okay. Not that much of important. Why? Because we are having of the at least the confirmation if cyclohexene is having. You know that one. The cyclohexane is having a two conformers. One is a chair form, another is a boat form. Chair form is more stable than the boat form because of the they're having of the below and above the carbon atoms are there. Boat form is having of the two carbon atoms are very close to each other. That's why this is a less stable than that one. That is the conformers we are explaining in the chapter. Now coming to the important one is
It's
the
also an important question, sir.
sorry. Tell me once again.
Is it also an important question, sir, for
Which one?
examination?
Which one?
Cyclohexane. Cyclohexane question, sir. Chair
Yeah,
confirmation, board
those
confirm.
informations they will won't ask up to now. I didn't given any time. I given mostly ethane and butane. Ethane. Why? Because again it will be cyclohexanes concerned of the you are having a heterocycle compound that is will be there now. Alicycle compound in the first cell. Alicycle compounds you are preparing cyclopropane, cyclobutane, cyclopentane like that. You are having Saxemora theory is there. Okay, in that you are giving stressing on that way of point of view. But here conformation isomers are so many other from the ethane onwards to hexane, heptane, iodine. But you are mostly concentration on ethane and butane only in this chapter. Okay. Now you
Okay.
go to the carbohydrates. This is an important one. We can discuss the carbohydrates, how the carbohydrates are classified, the classification, and also structural incitation of the glucose and the furanose, how the conformation takes place. This will be, we can discuss in that. I will go a little bit fast. This nothing is there. If you are familiar with the universe, where you are getting a intermediate stage also, this carbohydrates listen will be there. So what is a carbohydrate? Actually, our scientists are believe that carbohydrates means it is nothing but a carbon. That means we are having of the carbon is there. This is N numbers and water molecules H2O and M numbers or Y numbers, whatever it can take. Okay. That means carbohydrates is the water molecules. They are using of the hydrates of the carbon. They think of that. Carbohydrates. The meaning of the hydrate means water. But ultimately, it is not a formula. After the conclusion that the carbohydrates are not a water molecule, it is nothing but the carbohydrates are polyhydroxyaldehyde or ketone is called as carbohydrate. So the formula is removed out the polyhydroxyaldehyde or ketone. Polyhydroxyaldehyde or ketone or substance with the whatever the compound you are getting. Those are called as the are called carbohydrates. Now you take the carbohydrates are now in this case we are using of so many number of glucose is a carbohydrate, fructose is a carbohydrate, sucrose is a carbohydrate, maltose is a carbohydrate, lactose is a carbohydrate, starch is a carbohydrate, cellulose is a carbohydrate. See, these are the chart I given. Number of carbohydrates are there. In this case, you are know the glucose. Already you are familiar with the glucose. The formula of glucose is C6H12O6. And fructose, the same formula, C6H12O6. Where you get the fructose? Give the any example of fructose. Do you know the fructose? Are you eaten the fructose? Everyone. Honey is the fructose. Honey is consisting of the fructose. Your clustered apple is the fructose. Clustered apple. Okay. So that is fructose. Glucose means glucose D powder. They are getting of the carbon. Immediately they give the energy. When you take that one, that it will be easily hydrolyzed. You're getting off energy. That will be getting off the glucose and fructose. Coming to the sucrose. What is the sucrose? Do you know the sucrose? Every day you are eating. Every day you are eating. This also glucose also you are eating every day. The rice, chapati, whatever the glucose only. Dal. The sucrose is nothing but sugar. Your household sugar. That is called as the sucrose. That is C12, H22O11. Sucrose. Maltose. We are using the malt. Okay. Or less or something other malts we are using in the that one. Those are the called as maltose. C12. That is also same formula. Lactose. Where it is obtained lactose? We don't know. But you are drinking. Milk is nothing but the lactose. Milk is consisting of the lactose. That is the formula is C12, H22O11. Starch. You know the starch?
Present in potato, sir.
Sorry?
It is present in potato.
Potato.
Also in rice, sir. Rice.
Rice. You are decanted water of the rice. That is called as the starch. We are eating wastage only. We are removing the starch. The starch is consisting of the a carbohydrate. That is the formula of you are having of the C6H10O5 n times. C6H10O5 n times. Same cellulose also. What is the cellulose? Anybody knows?
Found in cells, sir. Cells. No,
Presence.
plant organisms.
Yes. The fibrous material which is present in the fibrous material in the plants. Okay. Leafy vegetables or any vegetables we are having a fibrous content will be there. That is called as the cellulose. These are the two rich materials which are present in the carbohydrates. These are the carbohydrates. In this carbohydrate, these carbohydrates are again classified into monosaccharides, oligosaccharides, and polysaccharides. If you observe, you will get the classification. The example in the examination, they will ask the classification of carbohydrate for the 5 marks. Monosaccharides. These are the monosaccharides. Why it is called the monosaccharides? You can't further hydrolyze. This is a single unit
We
only.
can't split it.
You can't split it or you can't further hydrolyze. When you are taking the glucose in your diet, this will be directly formation of ethyl alcohol. And it is hydrolyzed, your formation of the ethyl alcohol. And then next, ethyl alcohol is converted into the energy and carbon dioxide will be removed out, released out. So due to of the respiration process, what happened? You are taking that one and removing of exhaust out the carbon dioxide. This is the meaning of that one only. So okay, these carbohydrates will be taken out of this particular hydrolyzed. Okay, this is called as a monosaccharide. Coming to the oligosaccharides. Oligo means when you hydrolyze, two or more monosaccharide units will be formed. When you hydrolyze this one, you're getting of glucose or fructose, sometimes 2 units of the glucose. If you take the sucrose will be hydrolyzed, you're getting of the glucose and fructose. If you take the maltose will be hydrolyzed, you're getting of 2 units of the carbohydrates. 2 units of the carbohydrates. That's why we are using of for the small children, malt is used. We are taking of the as a diet, malt, a mixture of other ingredients, all ingredients that is called as a maltose, which will give the 2 units of the carbohydrates. Lactose, again you are getting of the glucose and fructose. This is hydrolyzed 2 units. That's why it is called as a oligo, means few, very few of the monosaccharide units are formed. This is called as polysaccharide. Poly means n number is given more than 10 monosaccharide. When you are hydrolyze this one, starch and cellulose you are hydrolyzed, you are getting of the more than 10 monosaccharide units will be getting of that one. That is called as polysaccharide. So polysaccharides means you are getting of C6H10O5 n times. Please remember the formulas and where it is obtained also you can easily. That is the sources of this one. The source also very important. Glucose, everything. That means your chapati, rice, dal, and remaining other products, glucose is obtained. Fructose mainly honey and also custard apple. Sucrose means sugar or molasses. Maltose means malt, that is a grains from the grains. There is sprouted grains. Mainly important is sprouted grains. You are getting of the maltose. Lactose is a milk. Starch is decayed water of rice or potato. Okay. Cellulose is a fibrous material which is present in any food material or a plants. From the plants, you are getting of cellulose. See that one, starch and cellulose. If you see the glucose, you can eat. Fructose you are taken. Sucrose you are taking. Maltose you are taking. Lactose you are taking. But starch and cellulose you are not taking properly. You cannot digest. Why? Because more than 10 units of monosaccharide units are there. More than 10 units of monosaccharide units. If you are digested our human beings, we are strong enough like that buffalo. Buffalo can digest cellulose. Grass, rich amount of the cellulose is there. Grass is the green grass is the rich amount of the cellulose will be there. They can take it as a animals, particularly goat, sheep, buffaloes, cow. They will take. How much they are strong because of that is. And even though you can't digest, but you can take the cellulose material and starch material in our diet, everyday diet. Because any unwanted things will be present in our body that can be removed with the help of cellulose material. Unwanted wastage of our organ, that means whatever things which are present in our small intestine and the big intestine, that can be removed out with the help of cellulose. Rich amount of the cellulose you are taking everyday diet, won't get the cancer also. Cancer is nothing but we are, what happened, the cells will be damaged with the help of other ingredients which are accumulated in our body, that will be removed out with the help of the cellulose. That's why a doctor will be advise or suggest every day in our diet, at least one time you can take the leafy vegetables. Why it is? Leafy vegetable consisting of not only the minerals, mainly important of the cellulose is there. So any unwanted thing is present in our body that will be taken out with the help of the taking of the cellulose. So mostly leafy vegetable, then we are having of the cabbage. Rich amount of the C vitamin is there, as well as the rich amount of the fibrous material is there. Then you are having of the ridge gourd. Okay, ridge gourd also consisting of a rich amount of the cellulose material will be present. And bottle gourd, rich amount of that one. These are all are important ones you are getting of the cellulose materials. Okay, raw materials, whatever you are taking of the, okay, that will be considered. These are the classification. In the examination point of view, they will ask the classification of carbohydrates. Carbohydrates are classified into three categories: monosaccharides, oligosaccharides, and polysaccharides. So monosaccharides are, you can't further split into other units. It can directly give the energy. Oligosaccharides are, if you are hydrolyzed, you are getting off 2 to 5 units of the monosaccharide units. Maybe a glucose or maybe a fructose or both, sometimes glucose only. Okay. Polysaccharide means more than 10 units of the monosaccharides units are hydrolyzed. When you are hydrolyzing, we are getting, these are called as a polysaccharides. Okay. That's you have to write in the examination, give the formulas, give the names of the compound, then only you can get the good marks. Okay. This is about the classification. Now coming to the general reactions of the carbohydrates. How can you using of the carbohydrate particularly? I'll write one more thing here. I can differentiate what is the glucose, what is the fructose. Just now I use it as the polyhydroxyaldehyde, polyhydroxyketone. I classified that one. This is aldehyde. CHOH. HO. See, how many number of carbons? 1, 2, 3, 4, 5, 6. This is a polyhydroxy. 1, 2, 3, 4, 5. Polyhydroxy aldehyde. Aldehyde is called as a glucose. This is called as a glucose. Glucose is nothing but aldehyde functional group is present. It is having of OH group on the left hand side. That's the right group. These are D glucose, L glucose. If it is OH group is the right hand side, D glucose, dextrorotatory, levorotatory. That you are having the idea of configuration of that one. Okay. So no need of worry about that. The D glucose, L glucose. D means dextro. L means levo. We are using of the dextrorotatory only in our carbohydrate. That means glucan D. Glucan D. D means dextrorotatory. This OH will be present on this side. This is a D plus glucose. Now you can recognize we are using of the particularly both the compounds which are having of the CHOH and also C keto group will be present. Okay. So the keto group will be if where is the keto group is there, where keto group does not present means we have to identify. Here the aldehyde is there. Next we are having of the CH2OH, C double bond O, CHOH. Okay, O. Okay, 1, 2, 3, 4, 5, 6 carbon. This is called as fructose. So we are identifying the glucose is consisting of aldehyde group, fructose is consisting of keto group. Keto aldehyde. This is the difference between the glucose and fructose. There is a keto group is the functional group is there. This is a aldehyde is a fructose, that is the aldehyde group. That means it can easily digest. When you're taking up the rice or chapati, immediately within 3 hours, it will digestion takes place. You are getting of the energy. Again, you are getting of the hungry. Again, you are take. But you are taking the fructose. You are getting of more amount of energy. Among the carbohydrate, whatever the given the least, glucose, fructose, sucrose, maltose, lactose, cellulose, and starch. In that, fructose is very, very sweetest sugar, sweetest carbohydrate. If you are taking of this 10 grams or 100 grams, it is equivalent to the 1 gram only. That means 100 times more sweeter than remaining other carbohydrate. 100 times that much of is there. So that's why using the example is honey. Honey is the best example of the fructose. Clustered apple is the best example of the fructose only. That means ripened fruit, completely ripened fruit is getting of the fructose only, not glucose. It will be converted into that one. If you take the two rich ripened fructose, that is a clustered apple. If you see in the morning hours we are taken, immediately you will getting of the sleep. Why? This keto group will be slowly hydrolyzed, formation of alcohol. Glucose is hydrolyzed, immediately getting of the alcohol. Then the alcohol will converted into energy and carbon dioxide is removed out. Here also, this particular fructose also, immediately alcohol is formed. That alcohol will be getting of the giddiness. Sometimes it will be getting of the sleep. That is the present of the fructose. These are the two structures. These structures general reactions of the carbohydrate in our page 131 is given as so many number of, that means glucose and fructose will be reacted with, that means the very important test for the aldehyde, that means the tolerance and failing test will be confirmation will be takes place, reduction of the tolerance and failing reagent, glucose and fructose will be, you can easily differentiate. And oxidation of the bromine water, formation of aldonic acid. This CHO will formation of carboxylic acid. By that, you can use the important aldehyde only converted into with the bromine water. And also iodic acid. This particularly glucose can consume the 5 moles of HiO4 for iodic acid. You are getting of the 5 formaldehyde and also 5 formic acid is formed by means of this one. But here the only 4 moles of the iodic acid is required. Why? Because one keto group is there. Due to that reason, we are using of this one. For iodic acid, oxidation states well. That is the reactions will be taken place. And next is ozone formation. Phenyl hydrogen is reacted with the